So today's our topic is oxides of nitrogen. Today's our topic oxides of nitrogen. Today's our topic oxides of nitrogen. So nitrogen reacts with oxygen and it forms a number of oxides. Actually, at room temperature, nitrogen does not react with oxygen. But at a high temperature, nitrogen reacts with oxygen and it forms variety of oxides. So, what type of oxides it formed? Let us see the list of those oxides. Formula. Next, name, oxidation state, after that physical state, and chemical nature. Physical state and chemical nature. Let us see one by one. After that, we will discuss the chemistry of each and every oxide in detailed manner. So the first oxide is N2O. It is called dinitrogen monoxide. Dinitrogen monoxide. So its oxidation state is +1. Its physical state is colorless gas. It is colorless gas. And its chemical nature is it is neutral. And its chemical nature it is neutral. So second oxide, that is nothing but NO. It is called nitrogen monoxide. Some other names are there, we will discuss. Nitrogen monoxide. So here the oxidation number is +2. Here it is also colorless gas. It is also colorless gas, and the chemical nature it is also neutral. Next, the third one, N2O3. It is called dinitrogen trioxide. Dinitrogen trioxide. The oxidation state of nitrogen is +3. It is blue colored solid. It is blue colored solid. And its chemical nature is it is acidic. And its chemical nature it is acidic. Next oxide. Next oxide, NO2. It is called nitrogen dioxide. It is called nitrogen dioxide. Oxidation state is +4. It is brown colored gas. It is brown colored gas and the nature is acidic. It is also acidic oxide. Next oxide. Next oxide, N2O4. This is dinitrogen tetroxide. Dinitrogen tetroxide. Here also the oxidation state is +4. It is again colorless, liquid or solid. Its chemical nature is again acidic. And the last one is N2O5. And the last one is N2O5. This is called dinitrogen pentoxide. This is dinitrogen pentoxide. The oxidation number is +5. Again, it is colorless solid. It is colorless solid. It is acidic oxide. That is about the name, formula, oxidation state, physical state, and chemical nature. Now we are going to discuss one by one the chemistry of each and every oxide. What is its magnetic property, how it is prepared, what about the structure, etc. All these we'll discuss now one by one. So the first oxide is N2O. The first oxide is N2O. So first oxide is N2O. N2O is called dinitrogen monoxide. Other name of N2O is nitrogen 1 oxide. It means that that one indicates that nitrogen is present in nitrogen oxidation state is +1. It is also called laughing gas. It is also called laughing gas. So why it is called laughing gas? When it is inhaled by a person, it causes hysterical laugh. When it is inhaled by a person, it causes hysterical laugh. That's why it is also called laughing gas. And it is colorless. And it is less reactive or unreactive. It is unreactive and it is neutral. And it is neutral. How it is prepared? So it is prepared by thermal decomposition of ammonium nitrate. NO3 always stands for nitrate. NO2 stands for nitrite. So when ammonium nitrate is subjected to heating, ammonium nitrate is subjected to heating. In this molecule, remove the possible number of water molecules. How many water molecules can be eliminated from this molecule? Here 4 hydrogens are there. So we can eliminate 2 water molecules. So remove 2 water molecules, then here 2 nitrogens, 1 oxygen, then you will get N2O plus 2H2O. N2O plus 2H2O. So name of this compound NH4NO3. Name of this compound ammonium nitrate. Next, one more method is there for preparation of this laughing gas or dinitrogen monoxide. That is nothing but a reaction of, this is the first method, and the second method is NH4OH made to react with HNO2. NH4OH, sorry, NH2OH. NH2OH we called it as hydroxylamine. Hydroxylamine. NH4OH, ammonium hydroxide. This is hydroxylamine. This is nitrous acid. HNO3, nitric acid. It is nitrous acid. HNO3 is a nitric, HNO2 is nitrous. So when these two are made to react with one another, first N2O is formed. After that, so if you remove N2O, then you will get two water molecules. Then you will get two water molecules. Next, structure of N2O. Next, structure of N2O. See how to draw the Lewis dot structure for N2O. For that, let us see. So here how many atoms are there? Total number of atoms. Total number of atoms is 3. 2 nitrogens and 1 oxygen. So to get the octet, to get the octet, number of electrons required is 3 into 8, total 24 electrons are required. Because according to octet rule, element must contain 8 electrons in the valency shell. So here 3 elements are there. So to get the octet, they need 24 electrons. But in N2O, the valency of nitrogen is 5. Nitrogen valency is 5. 2 nitrogens are there, 5 into 2, and oxygen valency is 6. So total how many electrons are there? 16 only. So total number of electrons, total number of valency electron, total number of valency electrons in N2O. Total number of valency electrons in N2O is 16. Now, the difference in number of electrons, difference is 24 minus 16, that is equal to 8. So, number of bonds in N2O is equal to difference by 2. Remember that. Difference by 2. Difference by 2 means how many bonds are there in N2O? 4 bonds are there. Now, put 4 bonds. Here, N2O structure will be like this. 2 bonds here, 2 bonds here. So, 4 bonds are nothing but 8 electrons. So, total number of valency electrons is 16. Out of 16, 8 electrons are present in the form of bond pairs. Out of 16, 8 electrons are present in the form of bond pairs. nothing but 4 bonds, 8 electrons. And how many electrons are left here? 8 electrons are left. So those 8 electrons, by using those 8 electrons, complete octet for the bonded atoms. Here this is the center atom and the bonded atom is oxygen. To complete octet for this, so here 2, here 2, here 2 bond pair, here 2 bond pair, total 8 electrons. Here also it has 2 bond pairs. If you place 2 lone pair, then it will get octet. This is the Lewis dot structure for N2O. This is the Lewis dot structure for N2O. Now, we have to mention the charges. So, in this case, the charge of the nitrogen is either positive or negative. In this case, in this case. Let us see, the valency of nitrogen is 5. It means that nitrogen has only 5 electrons in the valency shell. Here see, in this bond, one electron belongs to the nitrogen, another electron belongs to the nitrogen. These 2 electrons are donated by this nitrogen atom. So here nitrogen has 2 electrons in this bond, and here 2 electrons are there, here 2 electrons. Total, how many electrons belongs to this nitrogen only? 6 electrons. 6 electrons belongs to this nitrogen. But actually, nitrogen valency is 5. It means that nitrogen contains only 5 electrons. But in this molecule, during the formation of the bonding, here the total number of electrons for the nitrogen is 6. So it means it has 1 more electron. If it has 1 more electron, then the charge is negative, 1 unit negative. Similarly, in the same way, check that number of electrons belongs to this nitrogen only. So here 1 electron is there, another electron. Here 1 electron, another electron. So how many electrons belongs to this nitrogen only, not in the bond pair? So in this bond, this nitrogen donated 1 electron, this is another electron. So here 2 electrons are there, here 2 electrons are there. This electron and these 2 electrons belongs to oxygen. Oxygen donated electrons. Here nitrogen donated electrons 1, 2, 3, 4. So valency of nitrogen is 5, but in this bond formation, it has only 4 electrons. It means that it loses 1 electron. Then its charge is plus 1. And in this case, oxygen valency is 6, and its bond pairs and lone pair number of electrons donated by the oxygen 1, 2, 3, 4, 5, 6. There is no change in the number of electrons of oxygen. Hence, there is no charge in case of oxygen. This is the way of writing the Lewis dot structure for N2O. So in this case, we can write the one more resonance structure. That is, this lone pair is shifted here. Then, this lone pair is shifted here. This electron pair is shifted to here. Then what happens? Nitrogen, it contains 1 lone pair. It becomes a triple bond. This is double bond. It becomes single bond. Here the oxygen contain 3 lone pair. Here the charge becomes minus. Now it got 2, 4, 6 and 1 more electron in this 7. Here 2 plus 3, 5. Here again plus. So these 2 are the resonance structures for N2O. These 2 are the resonance structures for N2O. The skeleton for this structure is NNO. In this structure, it has a double bond. In this structure, it has a triple bond. In this structure, it has a double bond. In this structure, it has a single bond. So based on this, we can say NN bond length and NO bond length. Comparison between NN and NO bond length. NN bond length is less because here double bond, here triple bond, here double bond, here single bond. So NN bond length is 113 picometers, and NO bond length is 119 picometers. And the geometry of the molecule is linear. The geometry of the molecule is linear. So next molecule, next oxide of nitrogen, NO. So the other name for NO, it is called nitrogen 2 oxide. 2 indicates oxidation state of nitrogen. Oxidation state of nitrogen is +2. Again, it is a neutral oxide. It is neutral oxide and it is paramagnetic. Again, it is colorless gas and it is highly reactive. Because of its highly reactive, thermally less stable. It is thermally less stable. So it is paramagnetic due to the presence of odd number of electrons. 7 plus 8, it contains 15. So odd number of electrons, because of odd number of electrons, it is paramagnetic. In solid state, it exists in the form of dimer. Dimer means 2 NO molecules are combined with one another, it gives N2O2. In solid state, it exists in the form of dimer, hence it is diamagnetic. In solid state, it is diamagnetic. In case of gaseous state, it is a paramagnetic. And it acts as an oxidizing agent. It acts as oxidizing agent. Not only this, all these oxides are acts as oxidizing agent. Next, preparation. Preparation of NO. Preparation of NO. How NO is prepared? So NO is prepared from sodium nitrite. Sodium nitrite, NaNO2, sodium nitrite. When sodium nitrate is made to react with the sulfuric acid, then we will get 3 moles of NaHSO4. 3 hydrogens are replaced with 3 sodiums, and after that 2 moles of NO plus H2O plus HNO3 is formed. Plus HNO3 is formed. And the second method is oxidation of ammonia. 4 moles of NH3 plus 5 moles of oxygen to give 4 moles of NO plus 6 moles of H2O. 6 moles of H2O. When ammonia is subjected to oxidation, then also we will get the corresponding nitric oxide. Next, structure of N2O. Structure of NO, nitric oxide. Remember, NO is nitric oxide, HNO2 is a HNO3 is a nitric acid. This is nitric acid. This is a nitric oxide. This is nitric oxide. This is nitric acid. So next, structure of NO. So again we have to draw the Lewis dot structure. So again you practice these Lewis dot structures. Now, according to octet truth, total number of electrons required in the valency shell. Total number of electrons required in the valency shell. How many atoms are there? 2. So 8 plus 8 is 16. But the total number of electrons present. Total number of electrons, valency electrons. It's good to write valency electrons present is equal to, so total number of valency, nitrogen valency is 5, oxygen valency 6, total 11. So the difference is 16 minus 11, that is equal to 5. So 5 is a odd number. So number of bond pairs, actually odd number of, if you divide the number of bonds generally we will take 5 by 2, number of bonds difference by 2, but here difference by 2 you will get a fraction. That's why you remove one and after that you divide, then you will get 2 bond pairs. There was no fraction of bonds in between. That's why we removed one from that odd number. Then we will get the corresponding number of. Bonds, bond pairs. So in between nitrogen and oxygen, 2 bonds are there. After that, see here, total number of electrons are nothing but 11. Out of 11, 2 bond pairs are there. 2 bond pairs are nothing but 4 electrons. So 11 minus 4, it becomes how much? It is 7. So by using these 7 electrons, we have to complete the octet for the bonded atom. First high electronegative, first for this. So still how many electrons are left? 3 electrons are there. So 1 electron is there. So it contains 1 unpaired electron. Sometimes we will write the structure like this. It is present in the 3 electron bond. So it contained 3 electron, odd electron bond. So NO is one of the molecule containing odd electron bond. 3 electron bond is there. And for this resonance structures, we will write, sometimes what happened is, this electron shifted to here, and this electron is shifted to here. Single electron, not a double electron, single electron. When that electron is shifted to here, one single electron shifted to here, then the structure will be like this. Here this one again double bond is there. Again double bond is there. Now oxygen contain one more electron, one more single electron. These two are the resonance structures of NO. So in this case, the bond length is 115 picometers. In this case, the bond length is 115 picometers. Next, this nitric oxide is subjected to oxidation. This nitric oxide subjected to oxidation, it is converted to NO2 gas. NO is colorless and NO2 is brown color. So during oxidation reaction, the color of NO changes from colorless to the brown.